My topic is 4.6, otherwise known as composition of radical functions, and this is Emily O. And I will be writing on a whiteboard throughout this entire lesson because I'm just cool like that. So you guys are probably asking, what is a composition of a function? I can answer that for you. Just wait 1 second. It's going to happen. It's going to show up. Wait. Now, a composition of a function is actually a process by which of combining. Actually, just read the whiteboard. It's going to show up. Two functions, like you said, the f of gx thing and the f of x thing and g of x thing, where one function is performed first and the result of that is performed on the second function. I think that's what it's going to say. Please excuse my nose. And there is your definition for what it is. Do you like it? Because I like it. It's the heart. Examples. Let's start with one, why don't we? So, let's say there's a blue circle, and there was also a brown circle, let's per se, and they went to a park. The brown circle meets up with other brown circles, and the blue circle meets up with other blue circles. It's going to show you in a couple of seconds here. See, there's a brown circle, so they match up like how the f of x fills up the g of x, or the g of x fills up the f of x. It actually doesn't make sense. So, like, yeah, I'm kind of lost. I kind of confused you guys. It made sense in my head, but obviously not here. Now, symbols of composition of function is actually an open circle, not a closed one, because that means multiplication, but composition is actually an open circle, like the one you say there, like, oh, Emily, oh, if that makes any sense to you guys. Because remember, the closed circle means multiply, open circle is. Now, many of you guys are probably wondering, what's the equation? So here it is. The equation for composition of a function is actually not that bad. Do you see what I did there with the off? See, off, composition of a function. Wait, never mind. Doesn't make sense. Moving on, the equation is f with that little open dot g times x equals f of g of x, or g of f or x, however your teacher asks you to do this. And are you confused? Because so am I. Okay, so now let's start off with some simple problems, hearts. We're going to actually start off with a really easy one. I'm sorry that you can't read that up there. It says f of g of x for the equation. So you're supposed to insert g of x into the f of x equation. And in this case, the f of x equation is 3x squared plus 6. The g of x equation is x minus 8. So you take the x of 8 and you plug it into the x, into the f of x equation, causing it to look something like this. So, as you can see here, to make it into that equation, it'll be f of x minus 8 squared plus 6. So it would be 3x minus 8 squared plus 6. You would square x minus 8 and x minus 8. Many students make that mistake. So that factors out into x squared minus 16x plus 64 plus the 6 from the outside. You distribute the 3 into all of the factored form, causing it to look something like 3x squared plus 48x plus 188. And wait, let me try to think if I forgot to add, and then you do add the 6 at the end. So we are going to start with some more problems, and this time the f of 3 equals the square root of x plus 5. The 3 replaces the x in the f of x equation. So in this case, the 3 would go inside of the x, so it would look something like the square root of 3 plus 5, which is the square root of 8. And as you have 8, you can simplify it further to 4 times 2, or going on further, 2 times 2 times 2. And as you know, the index of the square root is a 2. And you would take, since the index is a 2, you would take the 2 out, as you can group 2 of them out. So you would take 1 2 out and leave the other 2 inside. So the f of x is the square root of x minus 8, and g of x is x squared, and the equation this time is g of f of x. So you would install the square root of x minus 8 into the x squared, making it into the square root of x minus 8 squared. The square root and the squared would essentially cancel each other out, therefore leaving it with just x minus 8 all by itself, and that's the farthest you can go. So that x minus 8 is g of f of x. So, moving on equations, let's try another one. F of x is the square root of x minus 3, and g of x is, sorry if you can't read this again, is x plus 1, I believe. That's what it says. So we're going to find f of g of x. So the x plus 1 moves over to the square root of x minus 3, the f of x equation, making it into x plus square root of x plus 1 minus 3, which makes it into x square root of x minus 2, which is the farthest you can go, unfortunately. So moving on to the next equation, f of x equals the square root of x plus 5, g of x equals 3x plus my 3x minus 1, and we're supposed to find f of g of x as well as g of f of x. And we are going to start off by finding f of g of x. So you take the 3x minus 1, you plug it into the x plus 5 equation, making it to the square root of 3x minus 1 plus 5, otherwise known as square root of 3x plus 4, which is the furthest you can go. Secondly, we are going to solve g of f of x. This time the square root of x plus 5 goes into the 3x minus 1, which is a g of x equation, making it 3 times the square root of x plus 5 minus 1, which is, the parentheses don't count, so just 3 of the square root of x plus 5 minus 1, which is the furthest you can go. And we are going to start a new equation this time. I'm sorry that you guys can't see the top. I forgot. I should have lowered the camera down. But f of x is the square root of x minus 3, and g of x is 2x squared. As you can see at the top, I wrote it down for you. First, we're going to find f of g of x. You would plug in the 2x squared into the square root of x minus 3, causing it to turn into the square root of 2x squared minus 3, and that's the furthest you can go for that one. And secondly, we would put the square root of x minus 3 into the 2x squared as f of x goes into the g of x and the g of f of x equation, causing it to look something like 2 times the square root of x minus 3 squared, and then you cancel the squared and the square root out, making it 2 times x minus 3, simplifying that into 2x minus 6, and that is your final answer. I apologize once again for not being able to see the equation, but the equation is at the top. 2x squared minus 3 is f of x, and g of x is the square root of 6x minus 2. We are going to find both f of g of x as well as g of f of x. As you know, to find f of g of x, you plug in the g of x equation into the f of x equation, making it look something like this. 2 times the square root of x minus 2 squared, 6x minus 2 squared, minus 3, the 6x minus 2 and the square root and the squared cancels out, causing it to just leave it as 2 times 6x minus 2 minus 3. You distribute that, so 12x minus 4 minus 3, which equals 12x minus 7. So we are doing the g of f of x equation. The 2x squared minus 3 would plug into the 6x minus 2, making it into the square root of 12x squared minus 18 minus the 2, as you did plug in the equation in. So the final answer would be the square root of 12x squared minus 20. Roll some dice to get our numbers for this random equation, and I got 14, 11, 10, and 4. So I decided the quadratic equation is 4x squared plus 11x plus 10, and the radical will be square root of x minus 14. So we are going to do the f of g of x equation. So we would plug in the g of x into the f of x, making the square root of 4x squared plus 11x, plus then you simplify that into a square root of 4x. Now going on to the g of f of x equation, you would plug the f of x into the g of x, so that would be 4 times the square root of x minus 14 squared plus 11x plus 10. The square root and the squared canceled out, causing it to look like 4 times x minus 14, which is 4x, minus 56 plus 11x plus 10, and that all simplifies out to 15x minus. It's a wrap. Thank you for watching how to do composition of radical functions, and I hope you learned a lot. Thank you so much. The end. Yay!